So let's solve the problem today of Leetcode. So now we have been given a root of a binary tree, okay, and the value of the target node target and an integer k, and we have to return an array of the values of all the nodes that have a distance k from the target node. You can return the answer in any order. Yes, here we can see that target node is given 5, and we have to find all the nodes which are at a distance 2. Here k is 2, which has been given in the question. Okay, so you can see it is at distance 2. The node 4 is at distance 2, and node 7 is at distance 2. So we have to return. So we have to return 7, 4, and 1. You can see. Okay, in the second example, only one node is there. Only one node is there. Only one node is there, and we have been asked to find the nodes which are at distance 3. As we can see, there is no node which are at distance 3 from this node, so the answer would be empty. Okay, so how to proceed with this solution? Means how to proceed with this question? What will be the approach? Let's go according to the problem. What's the problem? It's clearly it's clear that we just have to perform a BFS or a DFS considering this target node as a root node. Suppose if I consider this 5 as a root node, then what will happen? I will just have to, I have the tree like this. I have a tree like this. I have a tree like this. It will become 2, 7, and it is 4. Okay, and it is 3. 3 will become a child of this node. You have to just assume like that the tree has transformed like this. Okay, now if I have given this problem to you, won't you able to just find the number of nodes which are at distance k? Because what you will have to do, will have to just perform the BFS, and will just take whether and will maintain a distance, and the nodes which are at distance k, and you will just push that node in the vector. Suppose you go to left. Suppose you go to left, then you see here the distance has become 1. Okay, so it is not equals to 2, so you will backtrack from here, then you will call to this child, and then you will go, then it will distance become 1, then here you will go, distance will become 2, and now there is no further node, so you will backtrack again, you will go. One thing I forgot to, that the distance has become 2, which is equals to k, so we will push this into vector, and here also distance has become 2, so we will push this into the vector, and now you will call this node if it is not visited yet. What we have done till now in the BFS, we keep a vector visited vector also to keep track whether I will just visit the node if it is not visited yet. Okay, so here also I will do the same, and here you can see distance has become 1. Okay, so in this fashion you can solve this problem. Now uh, distance has become 2 at node 1, so I will push this. Okay, and there can be further optimization also. Suppose if you have encountered a distance equals to k, then you do not need to check further, because obviously the distance would be greater than k. Okay, so now how to do this? Let's see the code. Okay, I will keep a another map. Also, when we go to, how would we know that although it is given that it is a binary tree, how would you go to the parent node? Because we have seen that that these three node will come here, means we are assuming this is here. So how will you traverse to this node? Obviously we will have to store the parent node. Okay, so I will name this as parent, means it will store the parent of each node. Okay, now I will create another unordered map. Why unordered map? Because here the constraint is the number of nodes is 500, so there will be very less collision and the time complexity will be big of one using an order map. But if we use order map, then it will take log n. Tree node star bool. Okay, and name this as visited, means it will keep track whether this node has been visited earlier or not. Okay, now what if uh, what if k is equals to 0? If k is equals to 0, then we just have to, I will also declare a fun vector answer named as answer. So if k equals to 0, then what I will do, just push back the target itself, because that is the only node which are at distance 0. Okay, target well, I will just push that and I will return answer. Okay, there is no need to process it. Now I will just perform an in-order traversal for storing the parent. I am please note that I am performing this in order to store the parent node for each of the node. Okay, so I will pass root, then not required target. Target is not required. Then parent. Okay, that's the only thing we have required. So now let's write the in order void in order tree node star root. Okay, so map unordered map tree node star comma tree node star parent. I am passing it variable so that it will not be declared again and again, so that it will not be, yes, declared again and again, because if we pass it not without reference, if we pass it without reference, then it will be initialized every time this function will be called. Okay, so if root is equals to null, then return. Okay, now what I will do, if suppose left exists, okay, then what I will do, parent of root left is equals to root. Okay, and I will call this root left and parent. Okay, if root right exists, then parent of root right is equals to root, because if I am calling this 1, which is the right child, then 3 is the parent of the 1. Okay, so in this way. Similarly, if left is being called, so 3 is the child, 3 is the parent of 5. So okay, now let's write the main function which is dfs. Now I have to pass the target as a root, because I am assuming now that this target node is the root node now. Okay, there is no need of root parent, there is no need of root, so we will not pass it parent. And one thing visited, that's it, and also the answer vector in which we have to store. and finally I will return the answer. Okay, void dfs, void dfs tree node, tree node star root unordered map tree node star. Always ensure that you are passing it with reference because it will saves your memory, and in some of the codes you can get memory limit exceed if you have not passed with reference. So yeah, uh, this is a technique to debug if you encounter a memory limit exceed. Vector in unordered map tree star. Also you can I am performing the dfs, but you can have performed the same using the dfs. Okay, and one thing also, you should keep a counter. Okay, like for target, what I am doing. Okay, bool, then I will pass the visited. Okay, now if root is equals to null, then I would surely return. One thing I forgot to pass here, 0 for the 0. What I why I am passing 0? I will keep track of the distance through the distance. Okay, 0, then it will become 1, it will become 1, and whenever it will be equals to k, then I will have to push that. So I will also pass k. Now suppose you are at a node and the count has become equals to k. Count has become equals to k. Then you will push back root value and just return from there, because I know that if I go further, then the distance will be of course greater than k. Also now you will visit a node. Okay, whichever node you will visit, you encounter, you will visit it. And now, and one thing also, there should be a base case. If visited, if root is already visited, then we should return, because I will not traverse it again and again. It will lead to TLE. TFS. Now I will first go to parent of, that depends on you. Let's go to the left first, then root left, then parent, then visited. So I have not passed here in count in key. So when I go to, I will increment count by 1. Suppose if I am 5, if I go to 6, I will increment the count by 1. If I am 5, I will go to 2, I will increment the count by 1. Similarly, I will go to the DFS root, right, parent, visited count plus 1, okay. Then DFS root, not root, it should be parent of. Now I will go to the parent of root, parent, visited, count plus 1, okay. And one thing I forgot here is that parent of target, means parent of root should be null. There is no root of the, there is no parent of the root. Okay, so yeah, this seems to be correct. Let's run it. 10 mistake. If k equals to 0, expected number name or after division if k equals to 0. Vector intention where I have used, oh sorry, the curly bracket was here. Now it should be fine. Answer or pushback a root value. Line 28. But I have passed answer. Oh, I forgot to take the answer here. Answer, then count. Okay. Same mistake I have done here. Answer, then answer. So yeah, it is giving the correct answer. Let's submit it. It got accepted and it is faster than 46. Ignore this thing. These are not always correct. Okay. So let's talk about the time and space complexity. Obviously, the time complexity, you know that you are performing a VFS and in order traversal. So in order traversal, take big O of n, and BFS, you also know that it will take a big O of n because at max there can be three adjacent nodes itself. So what is the time complexity of BFS itself? When you learn the graph algorithm, it is V plus E. V plus E, where V is the number of nodes and E is the number of edges of a node that can be possible for a node. Okay, so here it will be linear itself. So I can say it will be linear. In total, it will be linear time complexity big of n. Now let's talk about the space complexity. You are using a parent unordered map for storing all the parents of all the nodes. So it would be obviously big of n, and for visited it will also be big of n, and also the recursion stack will take space big of n. So yeah, it will also be linear. It will be big of n. Thank you.